Dear students, welcome in the Education Department at SHAHD Association. Our lesson today is Galvanic Cell. Make sure to subscribe to our channel for more lessons and don't forget to activate the bell to stay notified.
Today we have three objectives. First, we will list the materials needed for the construction of galvanic cell. We will explain the mode of operation of galvanic cell. Finally, we will write the oxidation and reduction reactions.
Previously, in the Explore section, we discussed the transformation of energy that we face in our daily life. Today, we will take one particular case of this transformation of energy from chemical energy into electrical energy. This is defined by the galvanic cell. At the beginning of our lesson, we will list the materials that are needed for the construction of galvanic cell. First, to construct the galvanic cell, we need two beakers. We also need two metal strips, for example, copper and zinc. Keep a note here that one of the two strips must have tendency to lose electrons than the other. We also need salt bridge to connect the two beakers. We need also connecting wires to connect the two strips. We need a lamp to test if there is electricity or not. And finally, we need solutions that contains the two suitable ions. So for example, for the copper strip, we need a solution that contains copper ions. For the zinc strip, we need solutions that contain zinc ions. At this stage, now we can construct the galvanic cell and after bringing all the materials. Every step, we will show you a schema that describes this step. First, dip the zinc strip in a beaker that contains solution having zinc ions. The second step is that we have to dip the copper strip in a solution that contains copper ions. We have to connect the two solutions by a salt bridge. Also, we have to connect the two strips by connecting wires that holds a lamp. This lamp can be a voltmeter, for example. The lamp now should light up.
After we set the galvanic cell in operation, what happens? Zinc strip will lose electrons because, as we said, it has more tendency to lose electrons than copper. Then it will undergo oxidation. Copper will gain electrons and it will undergo reduction. This movement of electrons, it will generate electric current, and that's why the lamp lights up. The strip undergoes oxidation will get thinner, which is the zinc strip. The strip which undergoes reduction will get thicker, which is the copper strip.
In this galvanic cell, we have two half reactions that occur at different compartments that are called half cells. One half cell contains the oxidation half reaction. The other one, it contains the reduction half reaction. The zinc strip, which is called the anode because it undergoes oxidation. The copper strip, it's called the cathode because it undergoes reduction. Now, we will write the reactions that are occurring during the function of the galvanic cell. We will start by the oxidation half reaction, or what we call the anodic reaction. So we write as this: Zn, it gives Zn2 plus 2 electrons. So when losing electrons, we write the 2 electrons at the right side of the arrow. Now we will write the reduction half reaction, or what we call the cathodic reaction. So Cu2 plus 2 electrons, it gives Cu. At this stage, we can write now the overall reaction after writing the 2 reactions above each other. We eliminate the 2 electrons at both sides and we add. So Zn plus Cu2 plus, it gives Zn2 plus Cu. At this stage, we have to write the cell representation from the overall reaction. We will start by the anode and then the cathode. So we write as this: Zn slash Zn2 plus. We write the representation of the salt bridge as 2 vertical lines, and then we write the cathode, which is Cu2 plus slash Cu. We have another notation for the cell representation, and we write it as this: Zn slash Zn2 plus, and we write the word as it is, salt bridge. Then we write for the copper Cu2 plus slash Cu. At the beginning of our session today, when we said the materials needed for the construction of a galvanic cell, we stated that we need a salt bridge to connect the 2 beakers or the 2 solutions. So what is the role of this salt bridge? Let's see. When Zn loses electrons, the beaker containing Zn becomes more positive. When Cu gains electrons, the beaker containing Cu becomes more negative. Here it comes the role of the salt bridge. The salt bridge contains ions. The positive ions in the salt bridge migrates toward beaker becoming more negative, where the Cu is. The negative ions in the salt bridge migrate toward beaker becoming more positive, where the Zn. So now we can say that the salt bridge makes electron neutrality.
As a summary, what we talked today. We listed the materials needed for the construction of galvanic cell. We explained the procedure for the construction of the cell. We explained the mode of functioning of this cell. We wrote the reactions that occurs at every step and the overall reaction. We explained the role of salt bridge in electron neutrality.
Thanks for watching. If you like this lesson, make sure to subscribe to our channel for more. And don't forget to click the bell to get all updates.